Welcome to the UGC lecture series. In this lecture, we are going to talk a little more in detail about entity relationship modeling. So, basically we are going to understand a little more about specialization and generalization in this lecture. This is a very important concepts of extended relationship modeling, ER modeling, entity relationship modeling. So, now let us define first what we mean by generalization and specialization. In real world, what is the meaning of specialization is, you are studying engineering, specialization is you are in computer science and engineering. Now, on the other hand, what is generalization? Computer science engineering, mathematics, physics, you are all doing degree courses of BSc in this, but all these together is called generalized as a BSc degree. So, these are things that you normally have in everyday life, and since we are modeling these, let us look at what exactly it means. So, let us first take specialization. Now, specialization defines a number of subclasses of an entity type, and each subclass contains a subset of entities of the superclass. A subclass is defined based on, now this is where it is important, a subclass is defined, last lecture we saw about subclass, but here we are saying that a subclass is based on more on a more specific distinguishing characteristic of the entities of the superclass. Now, if you take a set of employees, that is what the example we took last time, or you can take a set of students. These students all have many common properties, okay, but there is one more specific distinguishing characteristic of this particular student which makes him to be a special subclass. Okay. On the other hand, generalization is the process which is opposite to that of specialization, and it is an abstraction process where we are ignoring differences among some of the entity types and subclasses and generalizing them into a superclass. So, these are two opposite or processes. Okay. So, you can also look at specialization and generalization as top down and bottom up. So, it depends on your application. Some applications you will be bothered only about the superclasses. Some applications which are specific, you may want to go down to the subclass. That is why we need to have the superclass and subclass. Otherwise, you could have gone everything as subclass, only the entities in the subclass, call all of them as entities and finish it. Or you can, if you are not bothered about too many details, you can just go to the superclasses, call all of them entities and finish it. But this process or this concept of specialization and generalization was brought in because some application required that details, some application did not require the details. For example, if you take employees and so on, only for the payment module you needed that they are hourly paid or they were paid salaried, but otherwise you did not need that. On the other hand, when you wanted the skills of the employees, you do not have to have that. So, it depends on the application. Now, so you can look at this as a top down or bottom up. Subclasses are specialization of superclasses and superclasses are generalization of subclasses. So, what does it allow us to model? Now, let us look at that. Attributes only applicable to entity subclasses we can model, and only relationships that are applicable only to entity subclasses we can model. So, again constraints also you can have as specialization may be total or it can be partial, just like we saw there beforehand for subclasses and superclasses. So, total and partial, and again subclasses may be overlapping or disjoint. This is very interesting, we will come to this, and subclass participation may be attribute defined or user defined. Now, look at this, this is total participation, this is, that means what does it mean? that all the employees have either an hourly salary or have hourly based salary or is a salaried person. So, and whose hourly cannot be salary, that is what is meant by this disjoint, that is these two subclasses cannot have common members, and this means that all employees have to take part either in hourly or in salary. So, it is a total participation, the specialization is total and it is disjoint. Now, if you look here, now it does not say that all employees has to have passport or driver license, it does not say that, that is not specified, and that is partial, and it says it is overlapping. What does that mean? Some members who have passport can also have driving license, and similarly can have driving license, or there may be members who do not have passport but have only driving license, or the other way around. So, but that we are not bothered about, but what we are bothered about is overlapping is possible, that is there can be members in this subclass who also belong to this subclass. And how the subclass participation is defined? It can be defined by the user, you can say that that is the subclass, or you can define it by the nature of its attributes. If it has some attributes, values, then it belongs to this. So, specialization is a process of defining a set of subclasses of a superclass, and the set of subclasses is based upon some distinguishing characteristic which we have already seen, it depends on some distinguishing characteristic. Example that we saw previously is a specialization of employee based on job type, and it may have several specialization of the same superclass. So, specialization and generalization is in a way similar to subclass superclass, based on subclass superclass, but we are going to bring in additional constraints of whether it is total, partial, whether it is overlapping, distinct. So, I told you when we drew the ER diagram in the last lecture that we will be talking about this more in detail. Another specialization of employee could be the method of play, which we have already seen. So, attributes of a subclass are called specific or local attributes, that is the name that you give to the attributes that is special only to the subclass. For example, typing speed was one example that of an attribute that belonged only to the subclass secretary, but secretary belonged to the superclass employee, but that employee does not have typing speed, only the subclass the set of entities that belong to the subclass secretary had typing speed. The subclass can also participate in specific relationship types. For example, a relationship belongs to of hourly employee. So, hourly employee can have a special relationship belongs to which is not applicable to other members of other subclasses. So, let us take a small example here. This is the same example that we saw before. So, here if you look, we will go a little bit more in detail here. So, here you have employee and he has name, SSN, birth. SSN is probably his primary attribute. He has a name. Now, any of these people, please note, employee has managed, these are the subclasses of employee. Okay, 3 different perspectives of subclasses or specializations, but all of them have a name, have a SSN, have a birth date and an address, irrespective of which class they belong to. Now, let us take employee. Now, please note here, this is distinct, that means an employee whose secretary cannot be a technician, whose technician cannot be an engineer. Okay. So, here we are dealing with only distinct subclasses, meaning entities belonging to one subclass cannot belong to another subclass. So, here you have 3 specializations of employee, 3 different specializations, one is this specialization, one is this specialization and one is this specialization, and this is secretary, technician, engineer, manager is another specialization, and hourly employee and salaried employee is another specialization. Now, already we have discussed about secretary having a distinguishing attribute typing speed, technician has some grade and engineer has an engineering type. Now, this manager manages a project. Now, all employees do not have this relationship, only the manager has this relationship. Now, here you again it is, now here all employees need not take part in this, what it means is all the entities of secretary, all the entities of technician, all the entities of engineer, all of them need not belong, or all of them together need not make up the employee set. There may be other employees who do not belong to any of these, which means this is not total, it is only partial. All employees do not take part in this. On the other hand, for this distinguishing, that is all employees have to be paid. So, they are paid either according to RD employee or according to salaried employee. There are certain organizations where this can be overlapping also, that is there can be some employees who are paid partially by salary and partially by hourly, but this particular application does not allow that. So, again it is distinct, it is not disjoint, it is not distinct, disjoint, it is not overlapping. And a salaried employee has an attribute salary and hourly employees has a pay scale, means hour, how much he is paid, and this hourly employee alone has a relationship attached to it where he belongs to a trade union. The salaried employee is not allowed to have a trade union, so he does not participate in that relationship. Suppose let us assume that everyone is allowed to, salaried employees also allowed to have belong to a trade union, then this relationship would have been attached here to employee and would not have been attached to only hourly employee. So, this gives a very clear picture of the the subclasses and specialization. Now, generalization on the other hand is the reverse of the specialization process, okay, and several classes with common features are generalized into a superclass. So, the original classes then become its subclass. So, example, if you take car, truck, they are subclass, I mean entities, they can be generalized into vehicle. Why? Because both car and truck become subclasses of a superclass vehicle, and we can view the car and truck now as a specialization of vehicle, and we can view vehicle as a generalization of car and truck. So, let us look at an example here. Here you have the car and here you have a truck, two different entities completely. Car has a license plate number as the key attribute, vehicle ID, maximum speed, number of passengers as price. These do not have the same attributes. You have a license plate number, you have a vehicle ID, and you have a price, and you have a number of axles, and you have tonnage. Now, I want to generalize this. Now, how do we generalize this? We generalize this like this. Now, this car and truck are combined together in vehicle. Now, a vehicle can only be a car or be a truck. So, and all vehicles, we are not allowing only buses and all in this application, we are allowing only cars and trucks. So, it is total participation. If you are having other types of vehicles, then it need not be total participation. So, we have decided on this total participation. Why disjoint? Because you can't have a car being a truck or a truck being a car. So, that is why this is disjoint. Now, what is interesting about this is, let us look at the attributes. Now, if you look at the attributes, here license plate number, vehicle ID are the only, and the price, they are the only common attributes. So, those three common attributes are put in the superclass, okay, and after these two are primary attributes. So, the subclass now, please note, need not have, most probably will not have, depends on the application, the primary attribute, and this also has a non-primary attribute. Now, attached to this you have the maximum speed and the number of passengers, which are special to car, and here you have number of axles and tonnage, which is special to the truck. So, this is how, so when we start on by designing a ER model or a EAR model, we may have car and vehicle separately. As we go on doing an iteration, it is not a one step process, though we saw in the last class how we did a walkthrough for a design, but what happens is it is not a one step process. So, as you go along, what will happen is you may find that there are two subclasses that can semantically and conceptually, because of the nature of the application, be combined into a single entity, then comes the generalization. So, most probably you will do that. So, for example, this is the generalization, and two entity types that we took into consideration were these. So, here you have a truck also. So, this is the one which we had initially, which we took, and we converted it to this. So, that is what we did, and we will continue upon what we are going to do about this. Now, in this specialization and generalization, we can place some constraints. Now, let us take a small break. Welcome back after the break. Now, before the break we were talking about the specialization and generalization. We are going to continue with that with some additional properties which some of which we have defined, but more in detail. So, first let us look at constraints on specialization and generalization. Sometimes we will determine which of the entities can become members of each subclass by a condition, okay, not determined by the application, but by a condition. So, the subclasses which are defined in this way through these conditions are called predicate defined or condition defined subclasses. So, condition is basically a constraint that determines subclass members, that is, if this particular entity has this particular constraint, then he will belong to a subclass. This is what we are trying to say, and we can display the predicate defined subclass by writing the predicate condition next to the attaching subclass or superclass, whether to its subclass, attaching it to the line which connects the subclass in the superclass. So, this is similar concept that we have seen before, but the only thing is we are putting that if the entity is this type, this is the condition or the which determines the subclasses. So, if all subclasses in a specialization have membership condition on some attribute of the superclass, then the specialized is called. Now, we said one is the predicate condition, that is, if that entity is having some condition, then it is called condition defined specialization. We can also have another type of specialization which is called as attribute defined specialization. So, if all the subclasses in a specialization have membership condition based on the same attribute of the superclass, then we call it as an attribute defined subclass. Okay. So, attribute is called the and that particular attribute which decides on this subclass division into subclass is called as defining attribute. Example, job type is the defining attribute of the specialization, where we define employee, we separate it into secretary, technician and engineer. It is based on the attribute job type. Now, if there may be conditions where there may be situations where no condition determines the membership, in which case the subclass is defined by the user and is called as user defined. So, here in this case, so now basically we are looking at how subclasses are defined. So, membership in a subclass is determined by the database users by applying an operation to add an entity to the subclass, and the membership is specified individually for each entity of the superclass by the user. So, basically how the superclass subclasses are defined is decided by has three cases. One is predicate defined or condition defined, one is attribute defined, a defining attribute, and or by the user. So, this is an attribute defined specialization in the EAR diagram. So, here we have job type, this is the attribute. This attribute actually defines whether the employee will belong, the value of this attribute of this employee determines what subclass he belongs to. So, actually here also you have the job type, this job type decides that he is a secretary, a technician or an engineer. This we have already seen before, that this employee superclass has three subclasses, secretary, technician, engineer, they are all disjoint and it is not total class, total participation, there are other employees also. But this job type is deciding for me, this value of the attribute job type is defining whether it goes to this subclass or this subclass. So, the entity's participation, not participation in which subclass it goes to is decided by the value of the attribute. Two basic constraints can apply to specialization and generalization. We have seen this, one is disjointness and another is completeness. So, disjointness, let us go a little more in detail. Specify that the subclass of the specialization must be disjoint. What does this mean? An entity can be a member of only one subclass of that particular specialization. Okay. So, please note each type of specialization, you can have employees having three specializations which we saw before. That is one was job type, one was based on the salary and one was based on whether he is a manager. That can happen, but in the case of disjoint, for that particular specialization, if you have three specialization on one particular specialization, a member of the subclass can belong, a member of the entity can belong only to one subclass, and this is specified D, which we have already seen. If not disjoint, then specialization can be overlapping, that is the same entity can be a member of more than one subclass, and this is denoted by the O. Next we have this total partial, again which we have seen a little bit in detail before. So, total specifies that every entity in the superclass must be a member of some subclass in the specialization generalization. So, when you take that particular specialization, every particular member should belong to I mean there is no case of members not belonging to one of the subclass for that particular specialization, and this is called by given by a double line. Partial allows you can have entities in the superclass which do not belong to any particular subclass of that particular specialization, and this is given by a single line. So, basically we have 4 types: disjoint total, disjoint partial, overlapping total and overlapping partial. So, generalization usually is total when you go from subclass to total, because the superclass is derived from the subclasses. So, when you are doing generalization you normally have total, you do not have partial. So, this is a disjoint partial specialization. Now, if you look disjoint partial, so which means disjoint and partial, we have seen this already. So, here we have this is an attribute defined subclass and it is disjoint and it is partial. Okay. So, this is an example of a disjoint partial specialization. This is an example of a overlapping total specialization. Please note those terms: overlapping total. I said that we have 4 types: disjoint total, disjoint partial, overlapping total and overlapping partial. We have 4 types. So, we are now looking at some examples. This was disjoint partial, now we are looking at overlapping total. So, look at this example. This is a part, okay. This part has entities which can belong to manufactured part or purchased part. All the parts must belong to manufactured and or purchased, and some parts can be manufactured as well as purchased, some entities can belong to both. So, that is why it is called overlapping, but all parts should belong to at least one of this, that is why it is called total. Now, in addition to this, specialization and generalizations can have hierarchies, lattices and shared subclasses a little more in detail or more complex. A subclass may itself have further subclasses specified on it. So, this is a typical hierarchy. So, forms a hierarchy or it is sometimes called as lattice. Hierarchy has a constraint that every subclass has only one superclass, that is it cannot belong to more than one superclass, then that means it has only a single inheritance, and so it is basically a tree structure. So, that is what is called as hierarchy. A lattice on the other hand, a subclass can be a subclass of more than one superclass, that means it has multiple inheritance, and which case it is called a lattice. So, let us take a case of a shared subclass. This is a lattice basically. So, you have employee, okay. This all we have seen before. Now, this part, he is an engineering manager, okay. Now, this engineering manager, he is a manager, he is an engineer and he is a salaried employee. So, this engineering manager gets from this subclass belongs to 3 superclasses or inherits from 3 superclasses. So, this is called as a lattice. And of course, you have 3 levels: employee, manager, engineering manager, employee, engineer, engineering manager and employee, salaried employee, engineering manager. So, this has 3 levels as well as it has multiple inheritance. So, it is called as a lattice. Now, let us look at another example a little more in detail. This is a lattice and the example is a university. So, let us look at this. A person, okay, has all these attributes, okay. Now, this person can belong total, that means he has to belong to one of these categories in a university. He is either an employee of the university or he is an alumnus of the university or he is a student of the university. This is how the application says. There are other universities where you also have parents coming into the picture, we are not bothered about that. So, here it says that when I talk about a person in this database, he has to either be an employee or he has to be a alumnus or he has to be a student, one of these 3. So, that is why it is total and it is disjoint. An employee cannot be an alumnus cannot be a student, but certain cases employees can also be students, but in this particular application we are not allowing it, we are saying it is disjoint. Now, let us look at, so that is this. Now, an employee can be a staff, a faculty, or a student assistant. So, we are allowing that. An employee can be a staff, a faculty, or a student assistant, and this says that it has to be total, it is disjoint, cannot be all the three, and please note there are attributes associated with it. Then the alumnus has degrees, and these are the attributes of that, and the student assistant has a placement, and please note this is inheriting, it is called a lattice because this is inheriting from student also and also inheriting from employee. So, that is why, and then here you have student can be a graduate student or undergraduate, cannot be both at the same time. You have one more level, student assistant can be a research assistant or a teaching assistant. So, research is a project, teaching assistant he is a course. So, look at all these, in this all the subclasses specializations are disjoints, you do not have overlapping, and you have lattice because this particular entity or subclass derives from three, he derives from employee and he also derives from student. So, that is why it is called that. The student has 2 specializations, person has 3 specializations, employees also has 3 specializations, student assistant has 2 subclasses. This has 3 specializations, this has 3 subclasses, this has 2 specializations. We have already seen what is a shared subclass, let us go a little more in detail of that. So, if you have only a single superclass, it is not called a shared subclass. So, a shared subclass is a subclass where you have more than one distinct superclass subclass relationship, and each relation has a single superclass, and shared subclass leads to multiple inheritance, we have seen that already. So, in some cases we need a model, we need to model a single superclass subclass relation with more than one subclass. Superclasses can represent different entity types, such a subclass is called a category or a union type. So, let us go to the next concept, which is called as category or union type. For example, in a database for vehicle registration, a vehicle owner can be a person, he can be a bank, or he can be a company. So, a category union type is called owner, is created to represent a subset of the union of the 3 superclasses company, bank and person. A category member must exist in at least one of the superclasses. If he does not exist in the superclass, it is not valid. So, what is the difference between shared classes? It is a subset of the intersection of the superclasses, where shared subclass member must exist in all the superclasses. Okay. Here it is not like that, it can belong to at least one. So, now let us take 2 categories or union types. So, you have owner, now this owner, here we have the union, that is the union. Owner can be a person, can be a bank, or can be a company, okay. And this owner of course owns the registered vehicle, and the registered vehicle is a car or a truck. So, you have 2 categories or union types, one is owner and the other is the registered vehicle. Other than that the attributes and special attributes are all similar. So, basically in this we have explained what is meant by generalization and specialization concepts of the extended ER model. Now, if you look at this, what we are trying to do is we are trying to place certain constraints on entity participation. So, basically entity participation is either total or partial or disjoint or overlapping. We also had something called union. The union is the opposite of that. From the instead of going from generalization to specialization, we are going to generalization. Okay. So, in this we have looked at specialization and generalization of EER model in detail, and I would like you to do the following exercise. I want you to explain the concept of specialization and generalization with examples, not the examples we have seen, take some other examples, say for example from some other database, supplier database or movie database or so on, and then draw an EER model for an employee database and include many more concepts, include all the concepts that you have in EER model, but do not extend the model that has already been given in this lecture, extend it with many more entities and relationships, and see how the specialization and generalization helps you. So, thank you.